Hello everyone, welcome to AI Anytime channel. In this video, we are going to build an application that will help you generate automated visualizations, and we are going to use something called LIDA, which is a new release by Microsoft. They have built a system that will help you automate this entire data analysis process, and that too powered by large language models. So you can see LIDA as a Panda's AI killer, I will say. And that, to be honest, Panda's AI, I think they were a little slow when it comes to working on the active issues or on their roadmaps. Now we have a new system that's called Lida by Microsoft, and it really looks promising. If I talk about Lida, the meaning of Lida is like loved by the people, and I when I show you the demo, you will believe that this might get a lot of love from the community. Okay, and let me first show you a quick demo of that what we are going to build in this video, guys. So if you look at here, I have a Streamlit application, and that's what we are going to develop in this video. And I have two options. One is summarize and the other is question based graph. So the good thing about LIDA is that it also helps you query your granular data. You have CSVs right now and the Excels and the other on the roadmap. You can upload a CSV file and you can generate different graphs based on different queries or questions. So it can look at your queries and then it can generate graph. How it does it, I will explain that in a very high level in a bit. Now, if you look at here, we have something called summarize and the other is question based graph. So let's first look at summarize here. And in the summarize, I'm just going to browse the file name, and this is the data I've uploaded. Let me first show you a data. It is the same data file that I have used earlier to build a CSV chatbot using Llama 2. I'll give that video in the description as well. You can have a look. That video is completely open source. Doesn't work that good, but now we have a lot of workarounds with Pandas AI and CSV loaders, blah, 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 right? Now, this is my source data. And if I work as a data analyst or you are a data analyst and you want to augment uh, your entire workflow using a large language model, this is the agenda in this video, guys. Now you can look at here. This is a 2019 world's different countries and their happiness score. So you can find out the happiness score, which is based out of 10. Then we have GDP per capita, we have social support, healthy life expectancy, freedom to make life choices, and I hope North Korea is below in this, generosity and perceptions of corruption. Now, these are some variables, the metrics, and based on this final score has been calculated. And you can look at here, Finland, it scores the chart here. Finland, Denmark, Norway, the Nordics countries are doing really good when it comes to happiness score, at least according to the data. Now, this is my source data, and I want to generate some visualizations or infographics using LIDA, and that's what this tool is going to help. Now, once I upload it here, I can find out all the details about this data set. That's what we do when we use Pandas, right? df.info, df.shape, df. Type, whatever, right? We do some basic analysis of our data frame when you use Pandas to analyze your data frames or CSVs or Excels. Now, if you look at here, these are some information. First, it talks about the file name, main column, which is overall rank. It gives you some sample that how does it look like, and it has number of unique value. It has country. You can look at some countries like Bulgaria, Mongolia, etc. Number of unique values. 156 countries are there in that CSV that I was showing you. Then we have score. We're talking about their score, and we have some. That's really good. We are also getting standard deviation, mean, and maximum of that particular column. That's fantastic, right? That's what we used to do with df.info or df.mean or max, whatever. And then we also have different columns and some information over here for that. I will just I'll minimize it here. That's how you minimize once you click here. Now, the interesting thing, guys, it also gives you questions, and I will cover what goal mean, by the way, in a bit. It has different, it has 4 major features: goal, summarize, visualize, and there's one more that we will cover it in detail. Now, if you look at the goal, the first question it gives me, how does the score of countries vary with their GDP per capita? Now, suppose if I am a beginner in a data analytics field, or even if an experienced person, when I see a data for the first time, I might not visualize in my mind that, okay, what kind of chart or what kind of graphs I can generate, what are the 2 3 different variables that I can consider, can I do a scatter plot, can I do a bar plot between two variables or two columns. Now this will give you a very high level quick overview. Okay, these are the possibilities that you can consider and you can draw it. Okay, you can use this tool or application. Now we have built this app, right? You can just upload your data and play around it. Now if you look at the first goal, it gives you the question. It also gives you how will the visualization look like. It says scatter plot of score versus GDP per capita. That's the heading of your graph. Scatter plot of score versus GDP per capita. Then it also gives you rational, which is really important. Now if you look at here, we have one goal, we have two goal, and then we also have the chart here, the chart which I only get it for the first rule, where we did chart and the first index of the list. That's what we're looking at, the first element of the list. We'll see that in the code when we're writing the code. Now if you look at the goal one, we have a detailed information about how are we going to execute that goal and get our chart or graphics or infographics, whatever. Now if you look at here, this is the question: how does the score of countries vary with their GDP per capita? It gives you a detailed information that this visualization will help us understand the relationship between a country's GDP per capita and score. Not only you just go and randomly generate a chart, but there should be a business logic, or there should be some logic behind that chart. That's what kind of value we're going to create, or what kind of impact it can create from a decision making standpoint. So that's what you're also giving you from rationally here. You can see the rational here on the it's string. Here is the visualization, and the other one is which countries have the highest and lowest score. So this is the second chart that I can generate, right? I can generate a pie chart or some other charts like that, and you can find it over here, bar chart of country or region versus score. And then we get a chart here for the first one, because we are only using the first element, but you can do a for loop, and you can also visualize other charts. I will show in the code when we are writing it. How does the score of countries vary with their GDP per capita? Now this is a summarization of your data. You have a large number of CSVs where you have a lot of rows inside a CSV file, or how can you just upload it here on a application and get a quick summary of your data, and also with some visuals and charts. That's the purpose of this, and also gives you with a lot of questions. And you can do, right now we have only 2 goals, you can do n number of goals. That depends on how what is the purpose of your use case. Now this is the summarized part. If you go back to, and let me just copy this here, guys. I'll just copy this here, and I will go to question-based graph. Now when you look at question-based graph or the query, we have a subheader here. It says query your data to generate graph, and here I'm just going to browse files. Let's browse the same file. It's already there, and here I'm just going to write that question that I've copied from there. You can also do query-based graph generation, and that's why its LIDA is really it's looking promising, because it provides rich contextual information to a large language model. Once you upload a data, right, a CSV file, which is granular in sense, right, it looks at the context behind your entire CSVs, and then it gives to a large language model which generate a chart. And it's a multi-generation steps. It's not a single generation step, and that's what they have provided a research paper. We'll look at it in a bit. Now here, once I click on generate graph, you can look at here, the app starts running, and here for this particular query I get the response from a visualization execution. There is an executor that works in the backend, and I have kept it verbose because I want to explain you that it first gives you a base 64 string over here. It's a base 64 in encoder value that you get it here. You have to take it and convert it to image. That's what I have done. Now you can look at it. Also gives you the code, by the way. Now if you want to use this code or run inside a backend process as well, you can also do that. And here we got our image for this particular query that we have asked. Now imagine how easy it makes it for me if I am not good in a data analytics field. That's the one area I'm looking at. Even if I am a very good data analytics guy, this can augment my entire day-to-day work that I am doing at my workplace. That's what the power of LIDA, guys, that Microsoft has released. Now this is on generating the graph. Here you can also set up a lot of instructions. For example, here you can pass an instruction in backend that, okay, give me graph of red color. It will set the color labels for you. So this kind of customization you can also do it, or I will say personalization you can also do it here. If you are, if you find some interest in different kind of color labels, etc., you can do it. So this is the application that we are going to develop. But before we go into the code, guys, let me first show you a research paper over here. You can read the paper here about LIDA. So LIDA in French, it basically, as I said, right, loved by all. That's what LIDA means in French. Okay. Now, if you look at here, it says automatic creation of visualizations, and it understands the semantics of data, the contextual meaning behind your granular data, which is really complex. A lot of people will have question that, hey, Llama 2 is not performing well for CSV data. And when we are building a chatbot, it will not do it, to be honest. It's still not there. Okay. So because even if it's an instruction tuned model, they are not that capable of performing really good. There will be wrong, false positive, there will be hallucinations, some gibberish outputs. At least GPT 3.5 or other closed source model performs a bit on expectations that we have when it comes to granular data. Now, this kind of frameworks, library or systems, whatever you call it, they're calling it a system here. The LIDA is a system. That's what they're saying. Now, this is really going to power that LLM workflow when it comes to performing well on CSV or Excels. So this is why it's important. It understands the semantics of data, enumerate relevant visualization goals. First create the goal and then generate. It's not directly generating it. It's a multi-step generation process. And you can see it over here. It says multi-stage generation problem. And they have different pipelines. And these are the four things that they features on their modules. One is the summarizer that converts the data into a rich contextual meaning, okay, of your CSV file. That's what it does for the first module, in a very natural language summary that an LLM can understand. Directly feeding an LLM a hell number of your numbers in your data frame, it's not going to work. LLM struggles with numbers and mathematics. There's no doubt about it. Now, if you look at the next part, which is Goal Explorer, it creates the goal and it find out the relevant query that you can ask to generate some graph. That's what the goal is. You can find it out over here. Then it has the visual generator that generates, refine, and the visualization code. And then it has infographer, generate infographics. That's the four modules it provides. I'll give the link in the description, but again, you can find it out yourself as well. It also has a GitHub repository that you can also read it. You can see here the four things that we are talking about. Okay, if you look at these four things, summarizer, which is rule plus LLM combined, and then the other is LLM only goal explorer. Once you give a natural language to an LLM, it will create some goals for you based on that natural language information that's available to LLM. And then it generates the graph and the infographics. They're the four module. And LIDA, one of my subscriber today just mentioned, right, when I'm creating this video, just 30 minutes before, I wanted to create a video on LIDA, and somebody, I think if you are watching it, I forgot your name, by the way. Somebody had just suggested me to create a video on LIDA, and that's what I also want to thank him as well. Thanks for suggesting me to create a video on this. Now let me just close this. Let me just close this as well. Now let's start developing this application, guys, and we'll explain a bit that how you can do it, and not only with closed source model, how you can also use models from Hugging Face. And I know that some of you might be interested into using a local model. So let's now start developing this application, guys. So to develop this application, guys, you can see I have a folder here that's called LIDA demo, and I will open this in VS Code. Let me just open this in code dot, and then it will open VS Code for me here. You can find it out. Let me just open it. Now here you'll see I have a requirements.txt. Now in requirements.txt, I have few libraries and packages. So LIDA, that is compatible with 4 different types of model provider, I will say. So you can use OpenAI models, and again Azure OpenAI is combined there as well. Then you can use Cohere model. If you have Cohere model, you can also use Cohere model. Then you can also use Palm models, like for example Vertex AI models. You can use Text Bison, etc. And then you can use HF model, which is Hugging Face model provider. So it does not support, or it's not compatible with quantized model right now. So if you want to use GGUF or GPTQ model right now, you cannot do it. You can only use the transformer based model which are not quantized. Okay, the autocausal model you can use. Now here, if you look at, I have Streamlit, that's the dependency of the Streamlit application. I have torch because I will show you, I'm not going to use HF model because that will probably take a bit of time. I will explain that how you can replace the OpenAI with an HF model there. It's just a single line of change that you have to make. And you might get an error that provider has an extra keyword or something if you are using LLM-X, because it uses LLM-X. I'll show you when I'm writing the code. You can see I have a .env file. One thing that you have to do, you need python.env as well, because I'm going to use OpenAI model here. In this case, I'm using GPT 3.5 Turbo, so I'm just storing it in an env file and just using it in a load.env. Let's create an app.py quickly here. Now here we're going to write the code. So let's do import streamlit as st, and then I'm going to use from LIDA. So from LIDA import manager text generation config and then the LLM. These are the required dependencies, the modules from LIDA. Okay, so we need a manager that will manage your LLM, and then the text generation config where we'll have some configuration related to a large language model, and then LLM is something that basically, that will so LLM is something that where you pass the name of the LLM. Okay, so let's see that. Now here I'm going to also use from .env import load.env, and I also need import OS, I need import OpenAI, and I need import, let me just do import IO as well, because we're going to use pillow here to save the image. We're going to get a seaborn type of image. Now from pil import image, and from IO import bytes IO, because we're gonna handle the CSVs, the uploaded CSV, and we're gonna need import base 64. Okay, okay, fine. Now let's do a load.env here. So let me just do a load.env, and I'm just gonna do OpenAI dot API key, and I'm just gonna get that from env file that we have using get env function, and this is the name that how I have defined in that env file. Now OpenAI API key. Now we are done with this, guys. Okay, so let's write a function, or I will not probably write a function. Let me just go to my GitHub gist, GitHub, and I will just, this is my GitHub, by the way. If you want any code of any of my video, you can just go and take it from there. Now in gist, I'm just going to copy this thing from here. Okay, so let me just copy this thingy. Okay, now copy and paste. Now what this function does, okay, it takes your base 64 string, okay, which is an encoded string, and then it gives you the image. Okay, that's what it does. It returns an image. Okay, so you can see it says use bytes IO to convert the byte data to image, because LIDA provides you a image which is like, it contains the base 64 of that image. So I have to use that on a Streamlit application, and that's why I'm going to convert that to an image. Now what we are doing here, let's have something called a variable here, LIDA, and here I'm going to use manager, and inside this manager I'm going to write, let's see, text gen, or you can also define it later, but this is how you define it, by the way. Even if you're not using it, we will override this variable later on. But now here I'm going to write LLM OpenAI. Now if you're using OpenAI, you're going to give OpenAI like this. If you're not using OpenAI, in that case what you have to do is you have to use LLM, and then you have to provide a provider. You can look at this, right? It says param provider. It takes a parameter that's called provider. In this provider, you have to give HF, and then you give model, yes, model, and then you give the model name. So for example, if you are using a model from Meta, or for example, if you're using from Together Computer, a Llama 232B model, then this is how it looks like. Okay, so something like this, Llama 32 key, and yeah, and then you can also pass a device map if you have a limited compute. Okay, so this is how you load a open source model. Okay, but that will take a bit of time on inference as well if you have limited compute power, like if you have a single GPU, or if you have very limited CPU memory there. Now this is what I'm going to do. Now let's have a text gen config. So how do you define a text gen config now? So in text generation config, what I'm going to do is let's write text generation config, and here this is just for, we are not going to use both of this that we are writing here, but this is just to show you. Okay, so here you can define a temperature, and for example 0.5, and then model, and the model is for example GPT. This is model I'm just going to use GPT 3.5 turbo, and let's use a 0301 model of turbo. Okay, and then let's also use cache equal true. Okay, so you can also pass, it also has a caching mechanism, so let's do use cache equal to true. Now this is how you define. So if you're using if you want to use an open source model, these are two things that you have to worry about. Apart from that, rest of your code will remain same. Okay, the model name will not be model, in that text generation config will look different. Okay, that's, you have to pass your provider, model, etc, etc. Now let's keep it like that. Now I'm just going to create a Streamlit thingy here, st.sidebar.select box, is it right? Yeah, and then here let's write choose an option or something. Okay, and here let's it's a list, so let me just write summarize, and then the second one is question based graph. Now this is the two menu that I'm going to have. Okay, now if menu, so if menu equals summarize, so let's, if menu equals summarize, then let's have a subheader here, st.subheader, and let's call this as summarization of your data. So a bit of, you know, decoration on the app. Okay, and you can extend this further guys. Okay, now let's have a file uploader, and in this file uploader what I'm going to do is we're going to use st.fileuploader. You define a label here, upload your file, and you can also define a type. I'm just gonna let's keep CSV for now. Okay, so type CSV, or you can just it's not needed to provide a list because we're only giving one value of extension here, which is type equals CSV. But if you have multiple, it's better to pass this as a list if you want to give XLS or something like that. Now file uploader is not none. Let's check that there is a value inside that somebody has uploaded a file, then only execute the rest of the code. Now here we have to save the file guys, because it except we have to get the value, the file name, that's where we have to pass. Now path to save, so let's just do path to save, and here I'm just gonna call it filename.csv. and if you don't want to do the coding alongside me, you can skip this part, but in most of my video I do coding, and if you want to follow it together, you can follow it. Otherwise you can just take the code from GitHub, or you can just go in the last, okay, of the last part of the video. Path to save filename.csv. Now let's save this. So with open path to save as f or as file, and then here what we're gonna do, we're gonna write this. So f.write, that will write on the disk, file uploader.get value. Yes, we're gonna use get value, not get attribute, sorry. I'm gonna use get value, and yes, now this will get the value of it. Now this is, we are okay with it, so this will save the file. Now let's have a variable called summary, and in the summary here we start using that module, one of the module we'll use here, so that's called Lita.summarize. This is the module we're gonna using. So you can look at Lita that we have defined on line 22. That's the Lita that we're gonna use here. Okay, that's the basically the variable, the model that we are using it. Now Lita.summarize, and in this what I'm gonna pass is, so in this let's pass the file name first. So this is the file name that we're gonna save. So filename.csv, and once you save it, we're gonna use, it has couple of methods. So default means it just give you can look at here, right? It gives you summary method, is string default. It has couple of more where you can have different type of summary, but I just need a high level summary of my CSV file. That's what I'm gonna use here. So summary equals summary method equals to default, and then just pass let's just pass text gen, okay, let's pass a text gen config as text gen config that we have defined on top. Let me do an alt G, and then you also use library equals library. So let me just do. Ooh. Okay, now we are done with this, guys. Okay, now we haven't defined the library yet. We need this library once we are plotting the chart, not now. Okay, so this will library is part of the visualization, not the summary. Okay, summarization. Now this variable holds your summary. Okay, the leader dot summarize. Now let's do that. So here let's write st.write summary, and this will just write the summary. Now once we write the summary, next step is to define the goals. So first was the summarizer, and the next part is goals. Now the LLM will have your summary, okay, in like on a contextual manner, and now it can look at those summary and can create some questions for you. The goals for the rest of the generation is step to generate the graph, the next module, which is visualization. Now in this goals, what I'm going to do is I'm going to use Lida.goal, and inside goals, it's not goal, it's goal. Pass the summary. You have to pass summary as an input parameter. That's the summary, and then number of goals that you want. Okay, so let's keep it 2 for now, because we are using OpenAI, which is a paid model, right? So you have to pay for it. Okay, so n equals to 2, and text gen config equals text gen config. That's what I'm gonna write. Now this goal is there. Now once you have the goal, at least as now we have 2 goals, we have to use a for loop here. So for goal in goals, and here we can just again do st.write, and just you can do goal. That's what you can do here. Now this gives us the goal. Now we have summary now, and we also have goal. Now the next step is to visualize, get the graph out of it. Let's do that. So what I'm going to do here is, and this is the only thing that we have to write here, guys. Most of the code for the next elif, which is question based graph, will copy paste. So I equals 0, and here I'm going to use library. It provides you different library. It has matplotlib or plotly also, or not plotly, I think matplotlib, cborn, d3. It has d3 as well. So for simplicity, let's keep cborn. Now in cborn, now after that I'm gonna again have a text gen config and text generation config here, and then let's pass for that n equals to 1. Only gives the one image to me. I don't want, so we are overwriting here, guys. Okay, so temperature, and temperature let's keep 0.5, and then let's use cache equal true. Now the reason I am not what I'm doing here, I only need one image. Okay, so n equals to 1. Now what I'm doing next is, once I do n equals to 1, okay, the next is charts. So let's have a variable called charts, and let's now visualize. So we started with summary, and then we saw goals, and now we're going to visualize it. So leader.visualize, and in this visualization I'm going to pass summary equals summary. So we are passing the summary, and we're going to pass goal equals goals, and you're going to pass, let's pass I here if you have n number of thingy, the goals, and then text generation config equals text generation config, and then here we're going to pass our library, which is cborn. Okay, so let's pass the library. Now if you want to use d3, if you want to use matplotlib, you feel free to use that as well. Now we have the charts. Now this charts basically holds a base 64 encoding, as I said. Now we have to handle that, so let's do it. So I'm going to call it image base 64 and image base 64, or let's call it image base 64 string, a little bit of self-explanatory variable, and then here I'm going to call it charts, and we only have the and that's called raster. I have done that exercise, so I know that has been called raster, that holds your base 64. So I'm just iterating, I have to look at the subscript of that JSON that I have, the list that I have. Okay, instead of JSON. Now charts dot raster. It's not a JSON, by the way. It's a list. Okay. Now charts raster. Now here I'm just gonna use image, and you can see on top we have this function. So let's utilize that function. So base 64 to image, and here I'm gonna pass that img thingy, base 64 string, and then just st.image. That's it, and this will give me the image. Now we are done with the first part, the first menu. Now next is elif. So let me just write it quickly. Elif menu equals uh, it is question based. So let's just write question based graph. Okay, question based graph. Let me just copy this thing from I'll just copy it from at least this part. Okay, now let's just copy it to make it a little quick. Come down to, okay, and let's not call it summarization. Let's call it query your data to generate graph. Query your data to generate graph. This is what I'm going to do. And file uploader, it looks good. Upload your CSV. Okay, upload your CSV. And file uploader is not none. Let's keep the same name, there's no problem. Let's change this at least because it will get overwritten otherwise. File name 1.csv. File, this looks nice, this looks nice, this looks nice. Now let's come out of with, okay, and we'll have a text area. And in text area, I'm going to use st.text area, and I'm going to write query your data to generate a graph, and let's have a height of that text area as 200. Looks nice. And if st.button generate a graph, let's keep that. And here if text area is not none or length of text area, let's do if length of text area is greater than 0, there should be a value, there should be value inside it, otherwise don't execute the rest of the code. Okay, now st.info your query, and it's a concatenation of text, so text area. Okay, this looks good. Now we have text area as well. And now again the LIDA. So let's have a LIDA which is manager. Let's copy this guys here. Okay, or where we, okay, and we can just use it by the way also, but this would have just called LIDA equals LIDA manager, text. This looks nice. Text generation config, text generation config. Let's use this text generation config. Okay, I'm just going to use text gen config from here, and I'm just going to paste. Let's call it 0.2 for this case probably, or let's also keep this really too high, 0.5, 0.2, and we are okay with that. Now this summary thingy, so let's get the summary thing from here. You can look at this summary thing. So we first need the summary, and this will become file name 1.csv. This is default is okay, text gen config is fine. And once we have the summary, now let's have an user query. So your user query is nothing but, what is that, text area, right? Okay, user query, you can directly pass it as well. Now let's have the charts. So in the charts, I'm going to pass LIDA dot visualize, and here we have to make a change, guys. Here summary will be summary, so let's do that. But your summary is summary, but your goal is not now the goals which is by default given by LIDA. Now this goal is an user based query. Okay, so the query which user has given, right? So that's what you have to do here. So your goal becomes user query. That's what your goal becomes now, and then text gen config becomes your text gen config. That's it, and we are done with now. Okay, so let's do, and this is how, if you want to do it in terminal, you can find out charts and the first of the list, and then you have, let's for example, image base 64, and then you can use chart 0.raster again, just to get the base 64 string from there, and then just have an image, and image equal to, let's use that function. What the function name? This is the function name, and let's pass image base 64 and then st.image thingy over here, and in the st.image I'm going to pass the image. That's it, we are done with our code, guys. Now let's run this and see if we are getting the response. But let me explain you, because after that I will cut short the video. Once I show the demo, I already have shown it. What we are doing here, guys, we have two things. One is summarize, the other is question based graph. Now we are using a library called LIDA, which is like a system that provides you flexibility of multi-generation steps, which generates automated visuals for your queries, okay, on top of your CSV file. That's what it does, okay. And it has some both open source and closed source model supports. Now this Lita gets OpenAI. We have some configuration, and then we have couple of conditionals. In the first conditional, what we are doing, we are getting the CSV from end user, and we are storing it, getting the value of it. And then we have three different modules that we are using. Apart from infographics, we have used all the three modules, rest of the three modules. The first is the summary, which provides you the contextual meaning, the semantics behind your data. And then it has goals, the LLMs, which looks at the semantics or the context of your data, generates some goals, which are the questions probably for the LLM to again generate an image or chart. And that's what it does, the visualize. That's what we're doing the first condition. Second conditional is more on the user-based query. If I have some query that I want to generate some chart for, I can use the second part of it. Now let's run this application and see if we are getting any error or it's working fine. Well, let me open the terminal, and here I'm just going to do Streamlit run app.py. Now, once I do Streamlit run app.py, I'm expecting that it will open the same app I was just showing in the beginning. Let me just quickly give you a high level walkthrough again. You upload the CSV, you can see it running. It has given you the summary first. This is the summary step, and you can extend this further, guys. You can put some more decoration, some verbose of like subheaders, header, etc. And you can look at the goals now. Okay, the goals that I have got. And you can also look at the chart that I have got, and this is really interesting, right? It's really helps you make better decisions on your data analytics workflow, right? If you want to have different type of charts, graphs, you can set the goal high, right? You can do n equals to 10 to get 10 different type of charts logic to get it quickly. And then you have question based graphs. Here you can ask the question that you want to ask in the question part. You can see it's generating for you. Let's take this now. We can take this one and try to see if it's like generating any graph or something for us. Now once I do that, probably it will generate, or it will be a messy graph, because sometimes if you generate bar graph or plot graph, you can see list index out of range, which perfectly fine, I guess, for me, right? Because it might be the index might be out of range for that particular graph chart, but you got the idea, I hope, right? So the code is available on GitHub. What I will recommend you to do is I will recommend you to try out the open source models, okay, with that. And I will give the link in the description, the Colab notebook that you can follow for that particular thing, open source model but you might get an error if you do pip install Lida, because let me just show you quickly what I'm talking about. When you want to use open source, if you want to use open source, you have to look at here. It says Lida. I want to show you the real dependencies behind this particular system that Microsoft has built. You have to come down and you have to search for the open source thing. You can see with locally hosted LLMs, and it uses a library called LLMX. Now there is an issue with LLMX. You have to downgrade the LLMX version to use Hugging Face models with Lida. So if you are facing any error with Lida, and if you're watching my videos, I will recommend you to downgrade the LLMX version. I can give you that in my GitHub link or the YouTube links description somewhere, that which version you have to try for if you are facing any error on Windows machine, because right now I'm on Windows. So I'll give the link in the description. Please go ahead and try it out. I really loved it because it's really promising, and I'm going to experiment something with open source on some other use cases. So that's all. I think this is what I wanted to show you in this video. If you have any question, thoughts, feedback for me, please let me know in the comment box. You can also reach out to me through my social media channels. The credentials are available on my YouTube banner and the channel About Us. If you haven't subscribed the channel yet, please do subscribe and support the channel so I can create more such videos. Please share the video and channel with your friends and to peer. Thank you so much for watching. See you in the next one.